All right, let's get started. We're going to create a new part, and today we're going to be making a uh, engine mounting plate. We're going to run it through some simulation. So we're going to start with is a sketch. We're going to select this top plane that makes sense, and I want to create a centered rectangle. So it's going to be drawn out like from the center here. Um, we'll do another one too. So these holes are going to be the mounting holes. These are going to be the overall size. And we're also going to have a little outcrop here, just like this, and another one right over here, just like this. Now we're going to dimension everything. So we can do Smart Dimension, change this, we're going to make it 12 inches tall. We're going to make this 18 inches. We're going to make this we'll go 3. That looks a little short. So we're going to go 3.5. And we're going to make this side here 2. Right, so now we're going to make this side and this side the same. So we can add some relations. So we know this, and this are equal. And same with this and this are going to be equal. And there we have that fully defined. Now we have this inside spacing here. So we're smart dimension. We'll go with 6 inches for now. And this one we'll go with 8 inches for now. Right. So right now, these aren't really highlighted in here, and that's okay. So what we're going to use is these trim entities tool, power trim. We just kind of snip that off, drag it through, and it recalculates everything. Makes it really simple. So here we have this kind of plane. It looks like this. Perfect. Now we're going to go to features. We're going to make it actually thick. We're going to flip it, and we're going to make it 1/4 of an inch thick. Just like that. Hit the check mark, and there we're done. So here's our mounting plate, but now we need the holes, the supports, and the holes over here. So next what I'm going to do is I'm actually going to unhide this sketch and show it. We're going to go to Hole Wizard, and we're just going to we'll go 1/2 inch holes, positions, select the surface, and just go right in there. We hit the check mark, and there we go. 4 holes. We also need the 4 holes over here. So real quick, here's the sketch. I'm going to get some points here and here. Smart dimension. Well, I will have them 3 inches away from each other. I will have this a little bit from the edge. We'll go an inch from the edge. And I know this is 2 inches wide, so we'll make that an inch. Same with this. They're fully dimensioned, but now we need them over here. So we can just mirror the entities. We can mirror it about. And we actually, since it's built off the center here, the origin, we can go into the Feature Manager design tree, and we can look at our planes. Our front plane is the one we want to mirror it over. It populates it over there. Hit the check mark. Everything is done. We exit. We're going to go back to features. We're going to go back to the Hole Wizard. And we won't do 1/2 inch this time. We'll go maybe 11/30 seconds. Positions. We'll select this face. We'll go here. And just like that, we have the other, the intermediate shaft rod, the connecting holes. So now, if you notice, these holes here, they're just holes. So it's actually supported by these holes from the bottom. So what we're going to do is we're going to create something called a split. We're going to do this twice. One for the engine where it is sitting and pressing down on this plate, and the other for the mounting holes on the bottom. So for the mounting holes on the bottom, we're going to create a sketch, and we're just going to draw circles in here because the tubing that it sits on are obviously circular pipes, so it works out. We're going to select all of them. We're going to make them equal. And then we can dimension one of them, and we can make it, let's say 1.25. Okay, so let's just say it sits on that. So now we can exit that. But if we were going to go into simulation right now, you would not be able to select these surfaces as something that is fixed. So what you can do is you can actually search split, and you can create a split line. You'll want to select projection. It automatically selects the sketch, or you can select your own. On the face, we hit the check mark, and now, if you look, we can select just that little circle. So what we're going to do eventually is we're going to select the inside and that's going to be fixed. All right, so next, we actually need where the engine weighs. So create a new sketch, do another center rectangle, we'll draw it out like this. I'm not sure what the base dimensions for it is, but we're just going to go with 4. And this is obviously very small by 6. So maybe it's not an engine, but maybe we just have this type of pattern that connects the engine mounting plate to the engine. And just for a little bit of extra math the computer has to do, we're going to fillet these corners. 0.3 is fine. Okay. But once again, you can't just select this sketch area, so we go back to split, split line, on this surface, sketch is selected, hit the check mark, and there we can select just this surface. So now, everything looks good, minus these really sharp corners. There's no way, you could do that, but I don't really want to. So we're going to go to Features, we're going to go to Fillet, and we're going to select each one of these edges here. And there probably is a better way to do this, but what else are you going to do with your time? So we're just going to select all the corners and be done. Now that we have that, we'll make it 0.25, just like that. We'll hit the check mark, done. Now, we're all ready for FEA. So what we're going to want to do, go to Simulation, hit Study. We'll just make it static for now. We're going to do something a little different later. But our fixtures, we have fixed geometry. So if we scroll or rotate around, now we can select these surfaces here. So we'll just select all of these surfaces, just like that. With the check mark, those surfaces are fixed. And next, we need to add external loads. So we know the weight of the engine, and it's all going to be on this specific part. So we can select that. We can go to English, and let's just say the engine is 65 pounds. Also keep in mind that for like this split thing, you'll draw out a sketch and it does the same exact thing. I just did it preemptively to make things much simpler. And now we need these here. So when you think about it, the load actually isn't originating at these points. So if I were to select external loads, well, force, and put on this, the load isn't originating there. It's actually originating at the engine, which comes down to this intermediate shaft, which pulls it this way. So what I actually want to do is I want to have an external load, a remote load or mass, scroll in, and while I'm still selecting all of these surfaces, it's at a different position. So this location, we need to change the location. So remember 0, 0, 0 is right here. So we can just mess around with the location. So it was 5, 5, 5. So now it's somewhere in this space at 5, 5, 5. once we go in further and we start translational components, whether it's newtons or whatnot, uh, then we have this. So as you can see, all the force on these are originating here. So it does all the like remote moment math and stuff like that. So what we actually want to do is there will be some y upwards forces, but there'll also be some um, negative x forces going to the left here. So we'll also want to select left. And we're going to go with, say it's 10 pounds and 10 pounds. I'm not sure what the actual numbers would be here, but notice how they're also facing the wrong way. It's not going to be facing that way. It's going to be facing this way. So it's trying to pull it up and left. But it also won't be acting directly over these holes. It's going to be acting further over here. So what we can actually do, and it's also going to be acting over a center line between these two. So what we can do is our x, we can change that to say 8. Well, that wasn't enough. So 9. And obviously this little thing's in the way. So now it's directly over that hole. If I actually go into the right view, it's almost directly over that hole. So maybe 9.5. And usually you'd have actual measurements on this. I don't want to go back and look, but it looks like 10 inches is fine. And we'll bring it out, down further, the Z, 6 inches. That wouldn't be far enough. So let's just say the pulley was there and the framing stuff was here. It's also pretty high. If you had a bracket that high, I would not recommend it, and I'm sure the computer wouldn't either. So maybe go closer to 2 or 3, just like that. So that's where the load's originating from. We hit the check mark, and just like that, you have a force trying to pull it up that way. This thing weighing down, and you have these fixed geometries there. So we're actually going to do, we're going to run, and it'd be helpful if I had a material, so we can go back to model and material. We can edit the material, and in this case, I'm just going to select some like pretty high quality uh, aluminum. You probably actually wouldn't use this aluminum for that piece, but we're going to do it anyways. We're going to run it. It's going to be like, okay, cool. It says our maximum displacement is 0.00, or it's basically 0.7 millimeters. So if we, that's how it's probably going to bend. If we put all these forces on it, and it puts a lot of stresses on it, and we can look at the stress right here. There's a lot of stress in this area here, and there's also a lot of stress there around the holes in general because this entire plate is weighing down. But if we look, we can go to factor of safety. We can just hit the check mark, and it says it's generally pretty safe. So this is the type of time where you might want to do topology or start cutting weight, or and start cutting weight. But what we're actually going to do is I want to right click on this and create a new design study. And there's a design study. It basically runs through the different parameters you set. So variables are things that change. So really quick, when you select a variable, you have the option to select a model dimension. So for example, it might be helpful if this thing was a little bit thicker. So we'll name this thickness. Its value is 1/4 inch for now. We're going to hit apply. We're going to select a new one. And what's also helpful is maybe if these holes moved too. So we're going to do hole width, or yeah, hole width. Apply it. This one is hole height. So as you move these holes outward, deformation over here is going to get less, but deformation in here is going to get larger. So it's like a trade-off thing. Hole height, that works. And then also, you can do other things than model dimensions. So you can do simulation stuff. You can do materials. So those are sometimes helpful. But we're just going to do thickness, hole height, and width. We're just going to hit OK. If I could delete this. Okay, we don't have to select it. Increase to A, and we'll select this one. Hit OK. So now we can just hold height and hold width. We do not have to select the A. So our thickness, lowest is an eighth of an inch, highest is 3/8 of an inch, step in eighth inch increments. That works. Whole height, or not height, yeah, whole height. Minimum of 3 inches. We actually want a minimum of 6 because of where it's at, and a max of 9. That works. Same with whole width. We want a minimum of 8 and a max of, actually this can go larger, so we'll go 15 instead of 4 inches. That's not even increments. I should just change it to 16 to make it even increments. You can change that step number, um, but it's fine the way it is. All right, and then finally, constraints and goals. The difference between constraints and goals is constraints is something it must have, goals is something it tries to get. So the options are generally similar. So with these constraints, you might need it to be less than a pound or something. Obviously right now it's 5.6 pounds, but it might need to be less than a certain amount of weight. So you can select monitor only, or is greater than, or is less than, or between. So there's a whole lot of stuff you can do with constraints and stuff. So let's add another sensor. There's mass, volume, all of these options. There's simulation data, and we're going to do that with goals. And you can select just about every single data quantity SolidWorks can calculate. And same with like measurements and stuff. You can measure stuff and constrain stuff like that. So I actually want to do goals. If our goal is the simulation data, and I want to, let's say, our displacement is going to be in millimeters because that's the thing we know. We want to not minimize it. Well, we could minimize it, but let's say I want it to change. I want this essentially design study to get as close to 0.5 millimeters as possible. And if you recall, the past design study was 0.7. So it should change it. Um, there's a whole bunch of other stuff you can add, like factor of safety, but we're going to do this for now. Active scenario is 18. All you have to do is select run, and I'll come back when it's done. All right, so we're back a few minutes later, and it tells us the optimal one is in green here. It's going to be 1/4 of an inch thick. Its whole height is 9 inches, full width is 8 inches, and it looks like uh, our deflection or displacement is very small. So notice what it did. It made sure the holes were as far out as possible, changing the moments and stuff, and torques going on it. So it says that this is the best way, but obviously there's conflict here, and that's okay because you know that something would have to change, and you know that the holes being wider helps the displacement out here. But we can actually do is we can head back to static 1. It keeps all of the settings. If we go to results, look at the stress is more evenly displaced, and displacement here. Um, Obviously, the middle, there is a lot of displacement, but it's still a lot less technically now that this hole is closer here. So it's moving a lot less. Also, this picture is very misleading because the scale is 766 um, to what it usually is. So it's quite a lot. But we can look at displacement here, and there should be a way to see it move. But look, if we look at our factor of safety, we still have a fairly high factor of safety. Um, Sometimes there's these weird things with the settings. So if we set our upper limit to say 5, the entire thing is going to be 5. So we do have a pretty safe piece here. And so that's basically how you use the design study tool. You can select more variables, constraints, and goals. and to further refine your piece. But as far as the the static was concerned, it just changed back. But as far as oh, interesting. If I actually go back to static, looks like it changed again. Um, but once again, if you just select the right one, like our factor of safety, the minimum is a 3.8. Our displacement, see now it says it's displacing 5 millimeters. So where was that first one at? Yeah, it's interesting because it says it's close to 0.5 millimeters, um, and it says that's what it is. But if we go to the static, uh, go here, it says it's 5 millimeters out here. So really, you just have to mess around with it, set your goals, um, and yeah, just enjoy.